Hi there and welcome to today's class. Let's proceed in the third method of differential equation known as method of solution of first order ordinary differential equation. This man here is the third method. Our first method was direct integration. Second method was separation, variable separation, right? Or perhaps we call it separation of variable method. While the third one there is called method of solution of first order ordinary differential equation. So put down please, copy down please. A differential equation of the form, a differential equation of the form, a differential equation of the form, a differential equation of this form is a first order homogeneous. I said a differential equation of the form this here is a first order homogeneous equation, that is the sum of the power x and y in each term are equal. I said a differential equation of the form this here is the first order homogeneous equation, that is the sum of the power x and y in each term are equal. Now listen please, listen. When it comes to solve problem under first order ordinary differential equation, when it comes to solve problem under this method, here's the idea please, listen. When it comes to solve problem under this method, the technique is easy. Your task there is to let y to be equal to v of x. So your task there, so let y to be equal to v of x. Now when it comes to this method, you are literally putting into values into consideration, or perhaps two terms. So when it comes to a solution under this method here, your task is to let y to be equal to vx, and also let the y over the x to be equal to v plus x dv dx. So when it comes to this method, your first priority is to put y as being equal to v of x, also put the over the x as being equal to v plus x dv dx. Now how do I got this value as v plus x dv dx? Here's the idea please. From here I have that y is equal to what there, v of x. Go back to differentiation. I have v, I have x. The two are multiplying. Obviously, I'll use product through method of differentiation. From product through, what do we know? We said the idea is simple. Let's say I have y equal to u dot v. From product through, said the y over the x equal to what there, v du over the x plus u dv over dx. Here's the idea. Let me call here 1, let me call here 2. Here's the idea for product through. Keep the second term, this second term constant, differentiate the first one. With respect to x, I'll have d over the x plus, keep the first one constant, differentiate the second one. With respect to x, I'll have dv over the x. Now listen, I want to show you how we got to v plus x dv dx. The idea from product through. How? We said y should be v of x. If y is v of x from here, I want to apply product through. So let's do a recap of product through. To recap, we said, let's say I have u, I have v here. These two multiplying. Let me call here 1, let me call here 2. To get product through is easy as keep the second term constant, differentiate this one with respect to x. I'll have v over the x plus, keep the first one constant, differentiate v with respect to x. I'll have dv dx. So this is what I'm saying please. If I have two to multiplying, the idea is simple. To get dy over the x here, so dy over the x here will be equal to, said, let me call here 1, let me call here 2. Said, keep second term, these two constant, so keep s constant, right? Differentiate the second term. This 2 is this one here. Differentiate this 1. So I'll have divided v, I'll have dv over the x plus, we said second term here, first term should not be here. That's v is the first term. Differentiate x with respect to the x. That gives you the x over the x. From here, I have that dy over the x is equal to x dv over the x dv over the x plus v into the x over the x gives you 1. All right, gives you 1. Let's proceed further. From here, it gives you dy over the x is equal to x dv dx plus v. So this is like one task to watch out for. When it comes to this method, your task is to put y as being v of x and put dy over the x as being v plus x dv dx. So I just showed you how we got to putting dy over the x as v plus x dv dx. This one can be expressed in this form as saying dy over the x now is equal to this v first, v plus x dv dx. This is how I got to this second substitution. So for this method here, your first substitution is this, second what is this. You have to put these two into the given differential equation question. After putting these two inside, it turns the equation, which is in form of x and y to become v and x. So the equation will change from x and y to v and x after putting these two into the differential equation question. Now the task there that how do you identify problems under this method? We said for differential equation, for direct integration method, we said the idea is simple as if we're given the value of the x to be equal to everything in x. That's for first method. Second method, that's variable separation method. We said to identify that one, you have a mixture of both x and y in the question. Now listen, you have a mixture of what? X and y in the question. Your first thing that comes to mind is what? Variable separation. So how do you identify problem under this? I will show you as we proceed in the study of method of solution of first order differential equation. So I'll be listing out what's it called there, the questions we're doing for this class. So let's list out the question we're doing. To write out the questions we'll be doing for today's class. So let's enter the tasks. So the questions we're looking at, number 1, I have dy over the x is equal to x squared plus y squared all over xy. Number 2, I have dy over the x equals x minus y all over x plus y. Number 3, I have dy over the x as being equal to y squared plus 3xy all over x squared. Number 4, I have dy over the x as being equal to x plus y all over x. Number five, I have dy over the x as being equal to y squared minus x squared all over 2xy. Next up. I have number 6 is given by dy over the x is equal to 2xy plus y squared all over x squared. Number 7, I have dy over the x is equal to y plus 2x all over y minus x. Number 8, finally, dy over the x is equal to 3y minus 2x all over y plus x. So we're looking at these 8 questions as we proceed. So I'll be doing this for you, please. I'll be doing this for you. I'll do 1, 2, 3, 4, 5, and 6. You do 7 and 8 for me. So you try 7 and 8 after you have learned how this works. So you do 7 and 8 and leave the answer 7 and 8 in the comment section for me. So I'll start with number 1 now. In the next class, we'll do number 2. Next class, 3. Next upper class, we'll do 4, 5, and 6. So let's start with number 1 example. So let's solve number 1 sample problem. All right, let's do number 1, please. First things first, I want to solve this problem. Your first task is that ask yourself which method will work here. Obviously, I can't use direct integration. It can't work here, right? It can't work here. So the method that can work here is either I use variable separation method or perhaps first order differential equation, or perhaps integrating factor, or perhaps exact equation. So whichever one works. So let me just show you how you can easily spot out this method we're working on now. Here's the idea. I have a mixture of both x and y. Must this be a variable separation? This man is a mixture of x and y. So I know my first task is I use idea of what? Variable separation. But it can't work. Why? Because we said for variable separation, your idea is that you take the term that has y and the y to the right hand side, take the term perhaps to the left hand side, take the term that has x and the x to the what there to the right hand side. I can bet you try take the term that have y and the y to the left hand side, to the right hand side, and take the term that has x and x right hand side. You can't do it. So in this case now, it's not possible to separate them. I can't separate x and y here. It's not possible. You try it. So this man, what? It's not possible. So variable separation will not work. Will not work. So my task now is to apply the third method now, which is called the first order ordinary differential equation, right? So perhaps the solution of first order differential equation. So I should apply this method now. Now for this method now, your first task in exam, because you don't have much time in exam, you're in exam hall and something like this of this nature. Your first task is to check, can you separate the variable? If yes, use variable separation method. If no, then use what? The third method here. For the third method, what do you say you do? It's easy as just put substitution. Your first substitution is to put y as vx. Second is what? To put what? The over the x as what? V plus x dv dx. So I'm saying that solution to this, please. Your first task, let y to be what? V of x. Also, take the y over the x as being x. as being v plus x dv dx. I said after putting these two into the equation, it will change the equation from y and x to become what there v and x. After that, you solve and factorize. Then you proceed to what there to solving it via variable separation method, and then you have your answer. So first task, let's write what v of x. Take what of the x as what v plus x dv dx. What next? So first task, this one here becomes this. That gives you v plus x dv dx is equal to x squared. I have x squared plus this is y, but we say y should be what? Vx. That gives you vx. This square comes here. I have this one here. All over I have x into this is y, but y should be what? Vx. I have vx. Why am I using this method? Because I can't separate variable. I can't separate it. So use this method, please. Next task there. Next task. Proceeding, please. This gives you v plus x dv dx is equal to, this gives you x squared plus v squared x squared. This man from indices. This square comes to the v power. The square comes to what? The x power. So I have this one here. All over x times x gives you x squared. This v remains v. I have this way. Proceed from here, please. Proceed from here, please. This gives you v plus x dv dx is equal to, now here's I there. Here's I there. My task says to factorize. So I want to factorize. Factorizing. That gives you what's common here. That's s squared. That gives you s squared into 1 plus v squared. Observe, please. S squared times 1 gives you s squared plus s squared times v squared gives you s squared v squared. So I factorize numerator. All over this gives you x squared into v. All right. X squared times v, see the same thing as x squared v. What do you observe? This will cancel this. So this part here, this portion here, is a portion you have to look forward to. Yeah. So for problem of this nature, you always factorize and it will sometimes cancel out. So this is what you should look forward to while solving this problem. Next task here, this gives you v plus x dv dx is equal to 1 plus v squared all over v. All right, we are here. Your next task is to move this v here. I'm left with what? X dv dx. X dv dx is equal to 1 plus v squared all over v. If I take a positive v here, it gives you what? A negative v. That gives you minus v. Of course, I have invisible one here. My next task is take LCM. LCM factorization are things you have to look forward to. You encounter it. So bear in mind. This gives you x dv dx is equal to, the LCM here gives you v, so I have v. So v in v is 1. 1 times this gives you itself, that's 1 plus v squared minus v squared times divided by 1 is v. Sorry, v divided by 1 is v. V times v gives you a v squared. All right. Obviously, plus v squared will cancel minus v squared. I have x dv dx is equal to, I have just 1 over v left. I have 1 over v left. Let's proceed. Let's proceed. Obviously, my next task from here, I'll have perhaps x times dv. That gives you x dv all over what there. This dx comes down as dx. As simple as that. X times dv gives you x dv. Dx comes down here. If you want to simplify this one here, this is how you simplify it. This way, in this way. That's how it works. So this is now equal to 1 over v. From here, I have 1 over v. So next task here, I want to try to use variable separation method here. I'll take the term that have x and the x to a particular side. I'll take the term that has v and the v to the other side. So looking at this place here, it's simple as take this dx here, or perhaps if you want to cross multiply, I have this time this gives you x v dv equals 1 times this gives you dx. So I want to make this x come here. That's the variable by x. So the variable by x divide by x at both sides. That gives you x v dv over x equals dx over x. Obviously, this one cancels this. I have v dv equals dx over x left. All right. Let's proceed. So my next task now is to integrate through. So integrating through, that gives you the integral of v dv equals the integral of dx over x. I'll separate this dx outside. That gives you, separate the x outside. That gives you the integral of v dv equals the integral of 1 over x dx. All right. If I integrate v, I'll have v squared over 2 equals, if I integrate this one, I have ln x plus c. All right. As simple as we said add, there's a 1 here already. So I said add on to the power. 1 plus 1 gives you 2. This 2 comes down here. If I integrate 1 over x, that gives you ln x plus c. Next task, take this 2 here. That gives you v squared equals 2 into ln x plus c. All right. Now, we are not asked to find v. The task is to make y subject so far. What we've done so far. Right? Our answer must have y equals the answers in x term. The question was given in terms of y and x. So it should not end with v and x. It should be y and x. So let's take back v. What do we know? We said y should be what? Vx. Make v subject. I'll have that v is equal to y over x. Anywhere I see v, I have y over x. So this v squared means y over x all squared equals 2 into ln x plus c. So it gives you y squared over x squared is equal to 2 into ln x plus c. All right. Plus c. I have this one here. Take this 2 here. That gives you 2x squared. Attach this 2 here. That gives you 2x squared. So proceeding. So that gives you, I have y squared is equal to, said put this x squared here. That gives you 2x squared into ln x plus c. All right. I'm asked to find y. Not, you can see that in this case now, they are both now in terms of x and y. So here's the idea, please. In this case now, I'm asked to find y, not y squared. What do? Take this square here, become a square root. That gives you y equals the square root of 2x squared into ln x plus c. Applying SOD, this can be written as y is equal to root x squared 2 into ln x plus c. All right, this can be expressed as, if I have root a times b, this can be broken down as root a times root b, right? So I'm saying, if I separate this one and this will cancel square roots, right? I've left just x, so x times 2 gives you 2x. I have y equals square root of 2x into ln x plus c. All right, this becomes the final answer after solving that particular question using the idea of this method, the third method, called method of solution of first order homogeneous ordinary differential equation. Let's proceed with example 2 in our next class.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, this membership program, as you can see the left hand side of the screen, you can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both. Right, so once you join the channel membership for other level students, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.